Okay, now for the firmware. Marlin has a number of example configurations, so when you've downloaded Marlin, you can go into the example configurations and you'll find a subdirectory for Creality, and in there an entry for the CR10S. Now we've got the CR10S5, and while they are for the most part almost the same, the bed size is very different. As a result, there are a few things that we need to change. Now, because I've also added the BLTouch, I also need to add BLTouch functionality. In order to make all this work, we'll have to scroll down till you find the marlin.ino file for Arduino, and when you double click on that, assuming you have got the Arduino IDE installed, it will launch and open up all of the files associated. We need to go across and find configuration.h, and we'll need to scroll through and make a few changes. My first major change was in line 94, and all I did there, the original file had it commented out, I just uncommented so that it would actually show the custom boot screen, since the configuration file, the example configuration, came with the boot screen. I didn't have to make any changes to that file at all, it works as is. The next change I made was line 136, and all I did was I added the 5 on the end of the machine name. Then at line 723, and this configuration file is pretty big. Up here, define probe manually. I had to comment that out. Previously it was enabled. Then 727, define BLTouch. We have to uncomment that one. Further on down, 789 or thereabouts. Right, we've got the X probe offset for extruder. I had to configure that to suit where my BLTouch is relative to the nozzle point. Now when you're setting those, everything to the left of the nozzle is considered a negative number, and everything in front is considered a negative number. So I've put those in, and my BLTouch is when it's extended, the trigger point is about 1 millimeter below the nozzle. I also changed this one from I think it was 10 up to 30, so it had a little bit more clearance. Because my probe is actually 30 mil further across than what the default is, I needed to move it in a little bit further so it didn't try and probe over the edge of the bed. Not a good idea to do that. Probing speed I increased from 8,000 to 10,000. This is just the speed at which it travels between the probe points. Then around in the 800s, $892 I've got in my list. Here we go. It's actually 877. X bed size. Now the default was 300, 400. I increased it to 500 because my bed is larger. It was at 300 for the Y, and down here the Z was at 400. I've changed that to 500 to suit this machine. Now the next change I made was down around 960. This one I uncommented, restore leveling after G28. So G28 is the G code for home the machine, and by default homing the machine will actually clear your bed leveling. So this restores the bed leveling after a home so that it will then automatically level the bed. The other thing I did was make sure I'm using bilinear. Now one of the other YouTube videos I watched suggested UBL, unified bed leveling. I actually found it took a lot longer to complete the unified bed leveling than what it did to complete the bilinear. And bilinear on my other printer has worked very well, so I couldn't see any reason for changing from that. I also enabled extrapolate beyond grid. Wherever that is. There it is, in bilinear, so it actually maps out not quite to the edges of the bed, so this will allow it to extrapolate past the edges of the bed. The next thing I changed was Z safe homing. Now this is actually a very important one to make sure you change. Define Z safe homing. If you don't enable that one, it will try and home in the left hand corner after homing, and that will put your BLTouch over the edge of the bed, and it will not home. It will crash into the bed and potentially damage it. Z safe homing will cause it to go to the middle of the bed and home there. You can, if you choose, change the position of the homing with the next section down, but by default it takes your X bed size and your Y bed size, divides it by 2, so it ends up being in the middle. It completes that after it's done at G28, so when you home X and Y, it does that first, and then it'll do the Z safe homing after moving back into the middle of the bed. Far better to do that than have it crashed ahead. The only other thing I did was in the status screen. The status screen contains a lot of graphics, and they're a very simple file. I'll actually open it up and show you. So it actually contains a list of animation frames. So each one of these sections from here through to here is the graphic definition. Each bit represents a pixel on the screen. If it's a 0, the pixel is off. If it's a 1, the pixel is on. And you may be able to read in this area, this is actually from the original 10S. You can actually see it's got a 300 in here. I've edited it to make that a 500 in the one I've put into production. When you go to compile this, make sure that you select the correct processor. If you don't, it probably won't compile, so you need the Arduino/Geno Mega or Mega 2560. Make sure it's selected as the Mega 2560. Select the correct COM port. Mine's not actually plugged in at the moment. Okay, so the other thing you should probably check is in configuration_adv.h. This is where our thermal protection is defined. Now on the CR10S5, it's the same heater as they've got on the 300 by 300 bed, but we're driving a 500 by 500 bed. That means it's going to take longer to heat the bed up. The downside of that is the thermal protection can trigger while it's still heating the bed, and so some manufacturers will actually disable thermal protection for this sort of reason. Now, to their credit, Creality didn't. They actually got round the issue by extending the time, and unfortunately in a vanilla default Marlin it's not extended, so we need to actually make sure we extend the time. Now by default it's set to 60-second period for watching the bed temp. We will set it to 120 seconds and look for a temp increase of 2 degrees. This gives it a little bit more headroom while it's heating the bed, because it does take longer, while not turning off the thermal protection. If a thermistor comes loose or a heater comes loose from the bed, there is still some protection, so we've got to make sure we leave that turned on. I think that was the only real change I made in here. Yeah, that was the only change, so we'll compile all of that. When it's finished compiling, it automatically starts uploading. It is a very large program that consumes a lot of the configuration space within the Arduino processor or the AVR microcontroller, so it does take quite a bit of time to upload. Now that it's done uploading, let's go through the process of setting up the bed, make sure everything is right, and our final calibrations. And we're now ready to run. So now we can test the controller. To be on the safe side, before we do anything, we will move the Now it helps if you turn the right way. The last thing you want is for the head to collide into the glass bed, so to prevent that from happening, we'll lift it up a fair way. And use auto home. So when it runs into my hand, it should stop. And now it thinks it's at 0. So we've proved that auto bed leveling does actually work. The BLTouch does stop it when it thinks it's 0. and it thinks it's hit something. The advantage with using that is I can put a different build surface on top of the existing build surface that is a different thickness, and it will automatically compensate. Okay, the next thing we'll do is re-zero it. This time we will go all the way to the bottom. One thing about this machine here is there is a lot of areas where you can tinker and improve on the machine. One of the things I'm not keen on is the spool holder. I think because the control box is so close to the machine in my case, I simply don't have much physical room for it to go any further away. I think it causes jam-ups, and that results in some bad prints. This is a print off this machine, and you can see where I've got layers that have been missed, and I think that's because the spool jammed up in different places, because it's so consistently on a single layer and not over the entire lot. But the bottom is perfect. Okay, auto bed leveling is easy to access now. At a bed leveling, I've already set the offset to 1mm after testing. So 0.01 is pretty much the standard for bed setting your nozzle height. Sorry, 0.1. I think before I do this I might actually heat up the Okay, now the bed's actually up to temperature, let's try calibrating our Z height. So 0.4mm too low. Too bad, maybe a fraction high. This is all trial and error. It's a lot easier on the Cocoon Create Touch, where it's actually got a function that lets you set the Z axis and actually adjust it up and down till it's just right, and then store that setting. One of the best things Sebastian Andrew did on the ADV i3++. although there are quite a number of really good features on that printer. Yeah, no, that's very good. Okay, so now we've finally got Z height tuned. We can now do a bed leveling. Okay, now that it's finished leveling the bed, going to prepare, bed level menu, and store settings. And you'll see the bed leveling is now turned on. So now, even if there is a warp in the bed, it'll still do a first layer reasonably well. That's all there is to it, and I'll see you on the next upgrade of this printer. If you enjoyed this video and like to see others, please subscribe, click the bell notification, and Google believes you'll enjoy these other videos as well. See you on the next video.